Hello, everyone. I trust you are all as well as can be. Thank you for joining us in this virtual gathering. My name is Dr. Seema Maliki. I am pleased to host this webinar and welcome you. This is Frontline Systems' special webinar on exploring decision trees and decision tables, other advanced capabilities in Analytic Solver. This webinar is another outreach from our dedicated customer success and support teams to make sure you are getting the most out of our products. During this webinar, we explore decision trees and decision tables. We start with building a basic decision tree together, step by step. Then we explore advanced examples on how to take advantage of Monte Carlo simulation and optimization capabilities in Analytic Solver to help with our decision analysis. After that, we look into DMN Decision Tables. We build a basic one together and review a few examples. As time allows, I will discuss more advanced features such as box function. So let's learn a little bit more about decision trees. Imagine you're faced with a complex decision. What do you have to do to best model this decision problem? Make sure you foresee all possibilities and organize your options with available accurate information. Clarify the benefits of each option. If needed, add uncertainty, then compare multiple goals and objectives at the same time with differing preferences, and then share your decision process with others. Decision tree is the right tool to help you accomplish all these goals quickly. Analytic Solver fully supports decision trees that are a useful graphical and computational aid for problems that involve sequential decisions and events, where there are a small number of decision alternatives at each step and a small number of alternative outcomes for each event. Furthermore, Analytic Solver allows you to incorporate uncertainty in and use optimization capabilities with decision trees. To model your decisions using a decision tree, the first step is to define the problem, determine if you want to maximize or minimize, for example, the expected value of an investment, profit, or cost. And decision tree is made up of nodes and branches. We have three types of nodes: decision nodes, chance nodes, and terminal nodes. Decision node has a branch extending from it for every available option. You will see they are drawn as squares. Chance node has a branch for each possible outcome. Chance nodes are circles. Terminal node, as it comes from the name, it has no branches. So, they don't have any branches succeeding from it and returns the payoff and probability for associated path. Terminal nodes are represented by triangles, and branches extend from each node. So let's look at our first example. Let's open Analytic Solver. Click on Help on the ribbon. Let's click on Example Models. So today's webinar is focused on this group of examples: decision tables and decision tree examples. Let's click on that. And for the first example, let's open 3 examples. This is based on an example by Professor Mike Middleton. It's a famous example, very straightforward. A firm must decide whether to prepare a proposal for a contract, and if the contract is awarded, what method to use to meet the contract needs. We are going to build this decision tree together. So let me show you how you can do this. I'm going to make this a little smaller. Let's click on decision tree. So let me actually highlight where we are going to work. Decision tree. So we are all in there. Today we're going to spend time in decision model group. Okay. Click on decision tree, node, add node. In this dialog, You have the 3 nodes that we talked about. Decisions, well, since we are just starting, the terminal is not available. You have decision nodes, chance nodes, and terminal nodes. So it's very straightforward to define a decision node. So let's call it decision. You can give it a name. So what is the first thing that the firm must decide whether to prepare the proposal or not to prepare it, right? And if they prepare proposal, it's going to cost them, right? So the cost for preparing the proposal is 50,000. Since it is a cost or they have to pay this, I'm going to put a negative value, right? 50,000. And not to prepare it, they don't incur any cost, so it's 0. And let's click OK. Now you can see we have the first part of the tree, a decision node and 2 branches. Automatically, it creates the 2 terminal nodes for you, but now we are going to modify. We have to think about the next step. We are going to prepare the proposal. There might be a chance that we get the contract and a chance that we might not. We're going to call this a chance of 50-50. So let's go back to the previous one. You can see we are going to work on this part of the tree. So we are preparing the proposal, but we are not sure if we're going to get it. So we have to have this probability incorporated. So let's go back to our tree. Select the node that you want to change. Go to decision tree, node, and then change node. That's just one way of doing it. Of course, you can add a branch also. Let's change this to a chance event because it has a probability, right, that it might happen or it might not. And we just keep the chances at 50-50. So what is the first possibility? We are going to get the contract. Awarded the contract. And then the second part is not awarded. And if we are awarded the contract, we're going to receive, or they will receive 250,000 upfront. Okay, so that's the cost, the benefit of doing this contract. 250,000. And it's a positive value because it's a profit, right? So let's click OK. And this is the second part of the tree. Awarded the contract with 50% chance and not awarded with 50% chance. If you are awarded the contract, what will happen? We have to decide how do we meet the contract requirements. There are 3 methods available: mechanical, electronics, and magnetic. Electronic and magnetic methods have possibilities of failure, but they are cheaper. Mechanical method works 100%, but it costs 120,000. And we have to meet the contract. So if we use magnetic or electronic methods and they fail, then we have to proceed with the mechanical method to meet the contract needs. Okay. Select this node that you have to change, decision tree node, change node. And this is a decision, right? Because we have to decide which of the 3 options we are going to choose. So we have a decision to make, which are using mechanical. Other one is electronic method. And the third one is magnetic. Now let's look at the values. Mechanical method, we talked about it. It's going to cost us 120,000. Electronic method will cost us 50,000. And magnetic method will cost us negative 80,000. So it was a decision to choose between these 3 options, okay? And these are all negative values. Now, mechanical is not going to fail, so that's the end of that one. So it remains a terminal node. Now let's look at the electronic and magnetic. There's a chance of success and failure. Again, I'm going to change the terminal node to which one? Chance node, right? Event or chance. So this would be, let's say, electronic failure or success. And the second one would be electronic. Okay. The chances for electronic success or failure are 50-50. And if we are successful at electronics, we don't need to pay any cost. But if we fail, remember, we have to meet the contract. And how do we meet the contract if this method fails? We have to go with the mechanical method. And how much that was? 120,000. So again, it is a negative value. Click OK. Now let's change the magnetic method. We'll be done with the building the tree. Let's go decision node, change node. Okay. And again, it's a event or chance. First event is magnetic success, and there's no cost. This one has a chance of 70%. Magnetic failure. And how much we have to pay if it fails? Negative 120,000 or 120,000. Okay, we are done with building the tree. So this is how you build the decision tree. Just took us a few minutes, 5 minutes. We have modeled this problem. Any questions so far? How to build the tree? Let's come back here. The first number below each branch is the amount that firm pays out, right? So remember here, for example, 50,000 was the cost to prepare the proposal. Or it receives, for example, if we are awarded the contract. Let's look at one path, electronic failure. Okay, so we're going to study this path together. Firm pays 50,000 to prepare the proposal. I want to show you how you come up with this 30,000 at the end. So we are going to look at this branch. How do we get here? From here, right? How do we get at the 30,000? So let's select an empty cell. We received 250,000 and then we spend 50,000, or you can just add up the numbers on the chart, right? 50,000 for the preparation of proposal. We tried electronic method, which itself costs 50,000. So minus another 50,000, which is this number in cell M16. And electronic has failed, so you have to pay another 120,000 for mechanical method. Look at the calculation: 120,000, 50,000, another. I think I put a 5,000 somewhere, and then 50,000, 250, and 50. So it's just sum of all these values. Okay, so the formulas are actually present in that cell. Okay, you can just see this one was 5,000. So if I put that 50,000, I'm going to get the 30,000. So you can see this calculation is pretty simple and straightforward. Okay, and then decision tree is solved by Excel formulas, overall calculating each of the numbers you see on the worksheet. One quick note, if you want to edit anything on the tree, best practice is to avoid doing it on the worksheet. If you want to edit these values that you entered, go to Analytic Solver decision node and edit them in the dialog. T18 is sum of all partial cash flows along the path leading to this terminal node, okay? And then tree is then rolled back by computing expected values. At this example, you can also choose or certainty equivalence at event nodes, and by maximizing or minimizing depending on what is the goal. And here we want to maximize the profit. Maximize or minimizing the alternative values at decision node. So the rollback values appear below and to the left of nodes, okay? Like for example, this one, 20,000 here, 90,000 here. The number inside the box, okay, at the decision node show you what alternative is optimal for that decision. Before going any further, let me show you something. If you go to task pane, there's a special group of options for decision trees. Under platform tab, if you scroll down, you get to decision model group. And here you have option for certainty equivalence. You can see the expected value is selected. You also have option for exponential utility function, and you can choose to do minimize or maximize as your goal, and other options that you can adjust. So we are working with expected value and maximizing here. tree will return the highest expected net value next to the initial node, which is here returning 1 for us. 1 in the decision node at this cell C31 indicates that it is optimal to prepare the proposal, which is option 1, okay? And then 2 here shows you that the firm should try the electronic method because it leads to a higher expected value of 90,000. So this 90,000 is actually just a maximum value between all 3 options. Since a decision tree is just a regular Excel worksheet model, you can actually ask what if. You can perform sensitivity analysis or create simulation or optimization model if desired. Before sensitivity analysis, I want to show you something else. There is a way to actually request the tree to show you the best path or highlight it for you. So highlighting the best here means which path is going to maximize your benefits, right? Or expected value of the proceedings. And this will highlight for you, this is the best path, okay? Now, you could also go to decision tree. So this will calculate the best course of action, okay? And then if you go to highlight the worst, it actually tells you to do nothing. This is the course of action that results in the least amount of loss for the company or for you as a decision maker. Now, let's practice some simple sensitivity analysis. Do not highlight, okay. Select B32 and then go to parameters on the ribbon and click on identify. The first parameter identified is I-17, the awarded contract fee. And what is happening here, just so that you get familiar with this tornado sensitivity analysis, at this bottom part, you can see we are changing the candidate cells 10% plus and minus 10%, and we will follow how B32 is changing according to this 10% increase or decrease. So if we change I-17, which is 250,000, and we increase it 10%, the upper value becomes 275,000, and then reduce it 10%, the lower value is 225,000. And then we calculate B32 for 275,000 as the awarded contract, and we get this value. Okay, so this is here. And then for 225, if the awarded contract is less, we come to here, right? Which makes sense. If they pay less, we're going to make less money. Any questions? For example, you want to see what is this value here for 275,000. It's really easy. You can actually go and try it yourself. Go to this node. Remember, we want to change it on the tree. Node, change, and for 250,000, let's change it to 275. Click OK. And you will see that now the calculation shows 32,500, just like the tornado chart for sensitivity analysis showed you. So either you can manually do all this calculation or take benefit of sensitivity analysis that is available to you in Analytic Solver. So we talked about decision strategy. Analytic Solver helps you to highlight your best or worst decision strategy, and it would be a sequence of decisions that you can make through the decision tree, okay? And it depends. Here we are maximizing expected value. If you change your goal to minimize expected value, everything will be reversed, right? So very straightforward. Any questions so far? I'm going to show you another advanced example. Let's click on help. Now we are familiar with the basics of building a decision tree, analyzing the tree, and getting the best decision strategies. Now, let's look at another example which uses Monte Carlo simulation to get a better decision analysis. Let's go to example models, decision table, and decision tree examples. And I'm going to show you launching a new product. Frontline system in this example is deciding if they should launch a new product. and the initial investment for launching the product is 900,000. This is in cell E23. If the product is launched, there is a 43% chance that the product will perform well, and the profit is 1,080,000. There is a 37% chance that the product will perform okay, and we only realize a 540,000 profit. And finally, 21% chance that product will perform poorly, and we only bring a profit of 162,000. So based on the values here, there's a good chance, there's a good chance that the market will be great. Once the probabilities and net revenues of each potential outcome are calculated, we are going to highlight, let's go to Analytic Solver Decision Tree, highlight the best, and you will see it is telling us to do nothing. And this is because the first year will result in expected loss of about 200,000, okay? That's the expected loss. But see, the problem with this model is it is not considering or taking into account several years of revenue. So it is telling us do not market the product. Let's look at another version of this tree. Here, they have added a second branch, which is this part, to test the market before releasing this product. They want to add this to see if they should first market the product before launching it. So you can see on the cost side, they're paying 50,000 to perform market analysis, and 3 different scenarios occur. Market will be great, fair, or it will test poor, okay? And 30% chance for market testing great, testing fair, or 60% for testing fair, and 10% that market will result will be poor, okay? After each of these, again, you have the option to actually market the product or not market the product. So you can see it's just the same branch is repeated. You can actually copy and paste the branch, okay? You can copy a section and repeat it. You don't need to manually enter all of this again. So let's look at one path in particular. Imagine you perform the test market and market performs great. So you already paid 50,000 to perform the test market. Market is performing great. And there is a 80% chance, remember, 80% that product will perform really good, and the profit would be 1,080,000. What is the expected gain if the market performs well? Anybody knows which number we're reading? 130,000, okay? So 130,000 is a realization of our gain if the market performs well after the launch, okay? And remember, 50,000 cost to launch the product, 900,000, and then expected gain and loss. We calculate everything, we get to this number, or just look at it and see what is being calculated. In other scenarios, if market performs fair, we're gonna lose money, 410,000, and if market is poor, we're gonna lose, we are going to realize a loss of 788,000. Now, in the next workbook, we are going to use uncertain distribution to replace static profit and cost values throughout the example. I-24 has a normal distribution. So rather than a flat 900,000 cost, the cost to market the product nationally will follow a normal distribution with the average of 900,000, a standard deviation of 25,000. Actually, M44, M64, and M84, all the down here, will also reference I-24. You can actually replace, but remember, even for replacing I-24, we didn't input it here. Let me show you how you enter it. Go to decision tree node, change node, and you see that we actually enter the normal distribution inside the dialog. You can also have reference to another workbook or another cell. If you click on run, simulate, run once, we are going to have histogram of outcomes for B39, which is different from the static outcome from previous model, which could be more realistic. You can also use optimization. I'm going to show the optimization example and skip it for today because we're kind of running behind. So let's go to example models, decision trees and tables. This one, the second example, submitting a proposal. This one showing you how you can use optimization to show the sensitivity of a decision to changes in probabilities. So feel free to explore that example. So this was an introduction to decision trees and more advanced examples on how to use Monte Carlo simulation, sensitivity analysis. You can also explore optimization. If you don't have any question, I'm going to move on to decision tables. DMN decision tables are another advanced capability in Analytic Solver. Decision tables are a good tool to use when there is a consistent number of rules or conditions to be evaluated, followed by a specific set of actions to be performed once the rule or condition is met. For example, you can have a decision table that returns an employee's pay based on the number of hours worked. Just to clarify, DMN provides a standard notation that is readily understandable by all kinds of users, including business analysts, technical developers, business stakeholders, from defining the initial decision requirements all the way to complex decision logics and automation of the decisions and how to manage and monitor these decisions. Okay, so for decision trees, we are following SFIL, okay, and we're fully compatible with DMN in Analytic Solver. I just put some information for you. If you're interested, this is a good website I found that teaches you about DMN if that's something you're interested. But remember, Analytic Solver is fully compatible with DMN rules, and decision tables follow FIL and DMN notation. Now, let's look into how to build a decision table. This is a structure of a decision table, and I'm going to open the example. We can follow it in the example together. So let's go to help, example models, decision tables and decision tree examples, and let's look at the decision table structure example. This table returns the number of vacation days given to an employee based on his age and number of years in service. The output here are the holidays the employee is entitled to and the rule that grants such holiday. And these are based on two inputs, age of the employee and years in service. So each table will have input variables. Here the input variables are cell G10 through H11. Each time the value of age and years of service are changed, you need to perform a recalculation of the table. This green arrow, if you hover over it, it says, this is the recalculation, okay? But if you hover over it, it says solve complete problem or run a simulation or calculate decision tables. So not only you can solve optimization problem, click on this, you can run one simulation when you click on it, and then for decision tables, you can calculate. So as soon as I click on calculate, it says calculation finished successfully. And here you have the output of the table. So if someone is 45 years old and has been serviced 15 years, holidays are calculated based on this number, 30 days, 2 and 2, and these are the rules that apply. Now we have a decision table function or side decision table that will return an appropriate computed results in this cell. And if you look, this is a side decision table. It includes the inputs, the table itself, and then gives you the output. And there's a decision table wizard that step by step help you to create decision tables easily. Let me actually show you other information, and then we come back and build the table together. There's a hit policy for each table. Here the hit policy is output order or O here. So there are different hit policies, and they specify how the table will be evaluated when multiple rules are applicable and multiple outputs are hence returned. So I have all the rules for you here. These are all the hit policies in decision tables. And if you're more interested in building your decision trees, for more information, go to user guide page 289. There are different data types that are supported in decision tables. You can have any, number, text, date, boolean, duration, time, and much more. So if, for example, this is someone who is 45 years old, let's compare if someone is 60 years old, enter the value, go to calculate, and you can see the rules changed. So 45, 3, 5, 2, 2. Okay, so enter the inputs. As the input change, you have to recalculate the table and gives you the outputs. So we have different rules or unary tests in each row here. Okay, so 1 to 8, these are all the rules you have. Let's go back to what was the person 45. When you do a recalculation, each rule is evaluated. And here, both unary tests must be satisfied in order for a hit to occur and the result to be added to the result collection. Here we have three rules in the result, right? Let's see how this happens. So first rule, under age, we have any age. Under service, we have any service. So first rule is age minus service. This person is 45 minus 15. It's going to be 30. Rule 1 is going to hit pretty much for everyone. This is why 30 is here and rule 1 is here. Let's look at rule 2. This is when age is greater than 60, which is not successful. So this one is false because age is 45. And we're just not going to hit rule 2 because both unary tests must be true. Let's look at rule 3. It returns true for age, any number, but service should be greater than 30. It doesn't hit. Okay, it's false. Let's move on to rule 4. Less than 80 is not going to hit. Number 5, greater than 60. The rule is not going to hit, right? Number 6, this has a potential. Age is anything, service is 15. No, it's not going to hit, right? Because service is this is greater than 30, our service is 15. Now let's look at rule 7. If age is between 18 and 16, 60, that's correct, it's 45. What about service? 15 to 30, both the unary tests are satisfied and we have a hit. So rule 7 is here with a value 2. So here we have the number of holidays based on each rule, and these are the two outcomes, holidays and rule. So rule 7 and number of holidays, and you can determine what you want in the output. Now let's look at the last rule. Age between 45 to 60, it is true. Service less than 30 years old, 30, it's true. So holiday is 2 days, and then rule is rule 8, and that is also presented in the output. So 3 rules are added to the result collection. And once we have this, once we are doing the calculation, the hit policy is checked. So the hit policy is rule order, and rule order specifies that if multiple rules are hit, the collection is returned in the priority order of the listed rules. So results are here 30, 2, and 2. So it might look first look a little complicated, but actually really simple how these are calculated. And let's look at how we can build this table together. So let's go to Analytic Solver, Decision Table, and first option is Add Decision Table. Here, let's give it a name. We call it Webinar Test. How many input parameters? We're just going to reproduce this example. We have 2 input parameters, age and years in service. How many output parameters? 2, holiday and rule. So let's put 2. What is the hit policy? Let's say rule order. So these are the hit policies I showed you in that slide. Let's click on next. Now, input parameter name. What are the inputs that we have? Age, and the second one is service, right? What is the data type? Let's just put number. So these are the data types we talked about. Let's click on next. What are the output parameter names? I call it holiday, and what was the other one? Rule. Data type, we just put holiday was number, right? And then the rule could be, I would just put any. Click on finish. So it automatically creates this table for you, okay? So now you can add the rules. Rule number 1, enter the values. Let's go to decision table, add another rule, rule number 2, add another rule number 3. And once you're done, add decision function, okay? That's the calculation at the end. So output parameters, holiday rule. I want to include the output names, just like the example. What is the input cell? Good question. Let me redo this again. Let's go back here. What is the input? This is cell G11 and H11. Okay, so let's go back here. Decision table, add decision function. Input cell for age, G11. Input cell for service, H11, right? And click on finish. And that's it. It just does the formula for you, side decision table, and all the calculation. So just in few minutes, you can build your first decision table. And then it gives you error because there's no rule and it's empty, right? There is much more you can do when it comes to decision table. I'm going to show you a very interesting example. Let's click on help, example models, decision table and decision trees. And I'm going to show you a loan strategy. There's so much you can do with these tables. This is a very interesting example. This is about the loan strategy. And first worksheet are the inputs. So we are looking at the different cascading decision tables that help us to decide whether we should give loan to an applicant. Okay, so probably a bank would use this. But you can modify for your own application. These are just examples to give you an idea of how you can organize it, how you can create dashboards. So this is the customer information, 40 years old, single, self-employed, credit score is 610, never been bankrupt, monthly income is 2,500, and monthly expenses are 1,000, and the loan that person is requesting is a standard loan with rate 5, terms 30 years, and amount is 100,000. Okay, let's look at the tables that deciding the fate of this loan. So we have 6 cascading decision tables, and first table returns a partial risk of default, a score based on loan applicant's age, so marital status and employment status. So we have 3 inputs, and then the output is 1 output, okay, partial score. And you can actually, if you want to recognize quick, is that this double lines, this column, you see this is double line that actually differentiates between inputs and then output. Remember, the person was 40 years old, right? Marital status was single, and the person was self-employed. So definitely we know, or let's calculate. So I'm going to click on green arrow to calculate, and the partial score is 104. Let's see how we get here. Applicable rules. This one, does it apply age between 18 to 21? No. Rule number 2, 21 to 25, no. 3, no. 35, 35 to 49. Rule 4 applies. First one is true. Marital status could be either, so it is true. And then employment status is anything. So this one applies. We have a 43. So let's put 43 plus. Let's look at rule 5. Greater than 49 doesn't apply, fails. Rule 6, any age, single, any employment status applies, plus 25. What is the next one? Let's look at this one. Is married, automatically fails, right? We know that doesn't apply. 8 is unemployed, doesn't apply. Student doesn't apply. Employed doesn't apply because the person is self-employed. Let's look at rule 11. Does it apply? Age is anything, marital is anything, self-employed plus 36. What is the total? 104. So you can see how these functions are calculated. So based on this, we have the next table. So we have the risk score, and is this an existing customer? Do we have a previous loan with him? And then we calculate the bureau risk category, and it comes with a medium category. Then we look at the call type. We do all this calculation, and we find the person eligible. And based on eligibility situation, the outcome or strategy comes at bureau. And the credit continuity factor comes at 0.7. You could also have some out-of-table calculations and use them in the table. For example, the affordability of person. If this person can afford the loan or not, so we have the monthly fee of the loan, monthly repay of the loan. So this is based on the loan terms. Monthly installments is monthly repair and the fee, and then monthly disposable income is their income minus the monthly install. And if this is greater than this value, person can afford the loan, and if not, person cannot afford. Okay, so this calculation can be done, and they can in fact be input to this to one of the tables or more than one. Since the outcome is zero, there's a post-zero table that decides whether they would get the loan or not. And you can see each table has different rule. And then we get a post-zero risk category medium, and then the routing comes to accept. So we decide to give person a loan. Okay, so this was like a more complicated cascading decision tables that are fully supported in Analytic Solver that are available to you. Since we are fully compliant with DMN, we also support box functions. Okay, this box function is on the ribbon. I'm going to just show you the example, and so you can explore it if you're interested. So let's click on help, and the example is under optimization examples. Go to example models, optimization examples, and scroll down to airport box function example. There is a lambda function in Microsoft Excel that allows you to define your own custom function written in Excel formulas without using any VBA. So we also created that in Analytic Solver so our customers can have their own lambda function. Okay, and Analytic Solver recognizes that, and we can analyze that with our SI interpreter. Okay, so lambda is supported. Also box function similarly, but this is notation. With the box function we have the notation of DMN. So this example, we're calculating location of an airport, and we have this optimization problem. We have all this calculation SURT of these formulas, okay, to calculate the distance of the airport. Okay, next workbook shows you how you can take advantage of box function. Okay? And you can see we are using box function for the calculations, and this is how you enter the function. Okay, again, it's very user friendly. Go to Analytic Solver, insert the box function, okay, and it will actually walk you through a step. We have a beautiful, easy to follow wizard to help you create the box function. Now, the next workbook shows you how you can actually use the custom lambda functions. Okay, this is the lambda calculations, showing you how you can benefit from these features. This is not following the DMN notation. This is just using the Excel formulas, but Analytic Solver again recognizes this. And these two allow you to use custom functions in Excel without using VBA. Because before you had to use VBA, write the code to create your custom functions. Let's go back to our slides for a recap. Today, we explored a few of Solver advanced capabilities that are available to you. We practice decision analysis with decision trees and decision tables. Remember that Analytic Solver is fully compliant with DMN business rules and fully supports box functions. These tools can enhance your decision-making toolkit with optimization and simulation capabilities, even data mining. So there was an example that you can look into. Email me at consulting@solver.com if you have any questions, if you want the slides, or if you need any reference for examples. Allison is here with us today. Allison, if you would like to speak up, you can unmute yourself.
Yeah, I just wanted to say thank you so much for joining today. We love getting to interact with our customers in any capacity, and we appreciate you taking the time out of your day to join us. Thank you, Seema, for a great presentation and spreading your advanced knowledge with everybody. It's greatly appreciated. Like Seema mentioned, we will be sending out the webinar recording and PowerPoint once it's uploaded on our YouTube page. And if you have any questions, please don't hesitate to contact myself or Seema. You can do so by the email information here on the screen. And we hope you will join us next month for our next webinar topic, and hope you all have a great day.
Awesome. Thank you, Allison. Sean, thank you so much for your positive feedback. I would like to thank you for joining us today to learn about decision trees and decision tables. We would like to wish you a wonderful rest of the day, and bye for now.